All right, number 87. The fish population in a certain lake rises and falls according to the formula F equals blah, 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 where F is the number of fish at time t, and t is measured in years since 2012. Okay, so t is measured in years, and as time changes, the population F, the number of fish in the lake, change. Okay. On what date will the fish population again be the same as it was on January 2012? So first, let's find out what it was on January 2012. To do that, we're going to plug in t into the equation. So the population size is 1,000, 30 plus 17 times 0 minus 0 squared. I did say this was a calculator problem, but you don't really need a calculator here. That's just 0, 0, 30 times that is 30,000 fish. So, let's plug that into the equation for F. 30,000 fish equals 1,000, 30 plus 17t minus t squared. So, this is a quadratic equation in t, so there's going to be two solutions. However, we already know one of them is t equals 0. We're just kind of looking for that other one. You can type this into the calculator using the solve feature. I think this one's actually pretty easy to solve by hand as well. However, I guess since it's a calculator problem, let's utilize it. Menu, algebra, solve, 30, 1, 2, 3 equals 1,000 times 30 plus 17t minus t squared. Comma x, comma t. So I got my equation, comma t. Solutions are 0 and 17. So told you. And then this other one is 17. So that's 17 years after January 1st, 2000. So that would be January 1st, 2017 plus 2019. Okay? Part B. By what date will the fish all have died? So if all the fish died, I guess that means there's a population of 0 left over. So the question is, when does F hit 0? At what time does F hit 0? So let's just set F equal to 0 in our equation. And again, this is a calculator problem, so we don't have to solve it by hand. I kind of want to just divide, well, whatever. Let's just use calculator. Menu, algebra, solve, 0 equals 1,000, 30 plus 17t minus t squared. We need to solve that equation, comma, t. So there's the exact answers. So apparently it wasn't factorable. If we would have completed the square, we could have got that answer there. If we want the approximation, we just hit Control, Enter, and it gives us our approximation. So we've got negative 1.6 and positive 12.6, or 18.6. So negative 1.6 and positive 12.6. Now, a lot of times people will just throw out this negative solution, and I guess we probably can here. Can't have negative time, but we can actually have 1.6 years before, before 2012. That would have been sometime in the year 2000 that it could have been equal to 0. I don't know if this equation, however, is valid for... I don't know what times this equation is valid for. I guess that's what I'll say. The wording of the question makes it sound like, you know, we'd measure... Well, whatever. This is my answer. However, I do want to... They didn't say how many years. It says by what date. So I do need to take this 18... In fact, I can even come up and grab... Oops. Last answer. Oh. I kind of want to go up and I want to grab this 18.6. And I want to convert that into years and months. Well, 18 years is going to put me at 2020, right? And then If I subtract the 18 off of that, this is the fraction of a year. Well, there's 12 months in a year, so if I take 12 times that fraction, last answer, gives me 7 months. So it's going to be 7 months from January. So January to February is 1 month. So to February to March, April, May, June, July, August. So that's going to be sometime in August. Now let's take the 7 out of there. That was the month. So this is the fraction of the month left over. So if I take, I don't know, 30 days, I guess, on average per month, maybe 30.2 or whatever, and multiply that by that fraction that's left over, about the 10th day. So I'm going to say August 10th. And you could even go further if you wanted. You know, it's all kind of rough approximation now. But you could say if that's the fraction of the day, so multiply that by 24 hours. So it'll be somewhere around 10 o'clock. Whatever. This is pretty close. Okay?